Welcome back, Master Gardeners, to today's Explainer. We're diving right into the living systems approach to urban tree stewardship. As horticulture professionals and community educators, you already know that a thriving urban forest doesn't just happen, right? It takes keen observation, rigorous science, and a real long-term commitment to the canopy. So let's just jump right in and look at how we can elevate our arboriculture practices for the communities we serve. Here's a quick look at our agenda for today. We're going to cover the living tree inventory, selecting the right tree, understanding tree growth habits, the fundamentals of pruning, and finally, cultivating community landscapes. Starting off with Section 1, the living tree inventory, which is about way more than just data. Let's look at the macro level and see how communities actually document their living landscapes over time. The Merced College Plant Walk is a brilliant illustration of what a successful, living database looks like. Just look at the sheer density of those green tree tags mapped out across the campus. This isn't some static map filed away in a drawer collecting dust. No, it's an ongoing, living system tracking thousands of trees. We're talking everything from Quercus agrifolia, our coastal live oak, to the ginkgo biloba. Every single data point represents a plant that was botanically identified by students right out there in the field. Now, a true canopy isn't built in a day, and while neither is its documentation, this project actually evolved over 15 years. Back in the initial phase, students and the local community literally put shovels in the dirt and planted about half of the trees you see mapped out today. Then, as the roots took hold, the project shifted into this incredible ongoing teaching tool. Today, students are continuously identifying plants, uploading fresh photos, and documenting planting dates, mulching cycles, the whole maintenance routine. I mean, this is exactly what true stewardship looks like, tracking the biological life of a landscape over decades. Moving on to Section 2, selecting the right tree. Science before the shovel. Because before any tree becomes part of a long-term inventory, we absolutely have to select the right specimen for the site. We do this by applying some pretty strict, unforgiving criteria. Using robust databases like SelectTree, a master gardener evaluates parameters systematically. Step 1 is always site conditions. What's the zip code, the USDA or sunset climate zone? What are the water use ratings and soil constraints? Only after the site dictates the possibilities do we move on to Step 2, which is tree characteristics. Here we evaluate maximum height, canopy width, and root growth shape. Finally, in Step 3, we get to the fun stuff, aesthetics, like flowers, fruit, and fragrance. But remember, reverse this order, and you're basically setting the tree and your community up for failure. But when we apply this precise selection process, we successfully place specimens that will genuinely thrive, not just barely survive. Take the Nisus sylvatica, or sour gum, mapped right there on the Merced campus. By deliberately filtering for a deciduous tree that reaches 30 to 50 feet in height with a 20 to 30 foot canopy width, planters ensured this tree was perfectly scaled for its specific spatial footprint. It's not going to buckle the pavement, it won't interfere with power lines overhead, and hey, it provides that excellent simultaneous fall color as a well-earned bonus. Section 3, understanding tree growth habits, focusing on form and function. Now let's zoom in a bit to the micro level and examine the fundamental biology that dictates how our selected trees will actually grow. Okay, the absolutely crucial concept here is apical dominance. This is the bud inhibition by the active growing terminal bud cluster on a currently elongating shoot. It sounds technical, but it's basically a biological mechanism driven by plant hormones that ultimately dictates the tree's natural architecture. If we, as stewards, don't understand how that terminal bud interacts with the lateral buds, well, we can't accurately predict a tree's mature form, and we definitely can't prune it correctly. Which brings us to a fascinating biological distinction. We've got to recognize the difference between excurrent and decurrent habits. Excurrent trees, think of conifers, actually have weak apical dominance in the current shoot, which lets the laterals grow, but they maintain strong apical control over time. That main central leader outpaces everything else, creating that classic cone shape. Decurrent trees, like oaks, are the exact opposite. They have strong apical dominance in their current shoots, but weak apical control year over year. The lateral branches vigorously break out and outgrow the main leader, and that gives you a spreading, round-headed form. And we have to remember that plant vigor heavily influences these expressions of dominance. Highly vigorous shoots tend to grow much more upright, directly challenging that main leader. As master gardeners, you need to be constantly evaluating the angle of branch attachments.
Narrow branch angles form incredibly weak bark-included unions with the main trunk. So an unmanaged, narrow, upright lateral, that's not just bad form, it is literally a structural failure waiting to happen in an urban environment.
All right, Section 4, the fundamentals of pruning, or directing the canopy. Understanding these exact growth habits directly informs how we approach canopy management, which is a practice that kind of seemingly contradicts itself by both invigorating and dwarfing a plant. Before you even think about making a single cut, you have to ask yourself, why are we pruning? There are really 5 scientifically sound reasons here. We prune to compensate for root loss at planting, direct the early growth of young plants, control mature size, influence flowering and fruiting, or to maintain plant health by removing dead wood and improving appearance. But the overarching goal? It's always to capitalize on the tree's natural growth habits so we minimize the need for pruning over time. Now, the crucial decision is choosing the right type of cut. Heading back, which is cutting to a stub, forces vigorous and highly unnatural upright growth right below the cut. It creates those weak unions we just warned about and casts dense, unhealthy shade. Conversely, thinning out removes laterals entirely at their point of origin. As horticulture instructors, we strongly advocate for thinning out landscape trees. It respects the tree's actual biological architecture, it controls size effectively, and it allows essential light to penetrate right through the canopy. You also need to know that the biological response to any cut is entirely dictated by timing. Let's look at this matrix. To encourage rapid development in a young tree, you've got to prune before spring growth begins, maximizing that active leaf period. But if your goal is to retard or dwarf a tree, wait until mid to late summer, just as rapid growth ends. That reduces its food-producing leaf area. For flowering trees, you really need to know your wood. Prune current season bloomers before spring growth begins. But for trees that flower on one-year-old wood, wait until immediately after they bloom. Otherwise, you're literally cutting off this year's show. And that brings us to Section 5, Cultivating Community Landscapes, Returning to the Macro. Let's look at how we take all this highly specific horticultural science and actually apply it out in the community. The Merced College Environmental Horticulture Initiative is pretty much the perfect synthesis of everything we've covered today. On one hand, you have rigorous academic discipline, understanding things like apical dominance and executing careful site selection. On the other hand, you have decades of community and student involvement actually getting out there, putting the trees in the ground, and tracking them. It proves that combining strict horticultural fundamentals with engaged, hands-on participation creates a truly lasting urban landscape. And the best part? This is a model any municipality can replicate. Which brings the focus right back to you. As you leave this explainer today, I really want you to start looking at your own streets differently. How will you steward the canopy in your community? Will you systematically use data to select the right species, apply biological principles to your pruning, and foster that long-term observation? The urban forest is a living, breathing system, and its future relies entirely on informed scientific stewardship from people like you. So grab your clippers and let's get to work.